Hello everyone! In this simulation, we're going to explore the effect of changing the mass of the train on its motion. We will neglect the friction at the moment. Notice that the mass and the driving force are set to 1. We will play the simulation. And notice that the initial acceleration is 1 as well. The train is accelerating forward. Now, I will reset the simulation and will select 2 from the drop-down menu of the mass, and I will click play. Notice that the initial acceleration becomes 0.5. The train is moving forward. Now I will reset the simulation, and I will select 4 from the drop-down menu of the mass and play the simulation again. Notice that the initial acceleration decreases to 0.25. How is the acceleration related to the mass? Well, as we increase the mass from 1 to 4, the initial acceleration decreased from 1 to 0.25. So we can say that the acceleration is inversely proportional to the mass. For a given force, increase in the mass reduces the acceleration, as mass is the property of an object which resists change in motion. And we have noticed that acceleration is proportional to the force. So we learned that acceleration is proportional to the force and it's inversely proportional to the mass. So acceleration A is equals to k multiplied by F divided by m, where k is the proportionality constant, F is the force, since it's directly proportional, and m is the mass, since it's inversely proportional. And from the definition, Newton is defined as the force necessary to give an acceleration of 1 meter per second squared to a mass of 1 kilogram. Therefore, the equation A equals k multiplied by F divided by m, the constant of proportionality is 1 if the quantities in the equation are in the SI unit. Thanks for watching.